what do we see in bioreactors? We can also see it in a coffee cup. If you add, for example, milk to a coffee cup, you will see if you don't mix adequately that you will have a cloud of milk, and the milk is not equally distributed in your coffee cup. If you would, for example, measure with a sensor, and you measure at the right side or at the left side, you will have a different milk concentration. And this is actually just the same in a bioreactor. Bioreactors really have a lot of gradients. Here you see it at the horizontal section on the top view, and this red zone indicates high concentrations, this blue zone low concentrations, and in the vertical cross section you see the same. So also there, where you measure will have a major impact on your emissions, on what you estimate as your emissions. So yeah, coming back to maybe now go to a practical example of what this can mean for a full-scale installation. So importance of sensor location, of course. So this is a plant in the Netherlands. We already showed it, and we will zoom in a little bit more here. So here you see, and the red stream and the blue stream is actually in the anoxic zone, where the denitrification is happening. So the influence and the return sludge stream mix together with the internal recycle stream. But if you look at those lines, you see they are actually not really mixing with each other. And actually this results in some gradients as well. We already saw this top view of the reactor, where you see that here after, right at the end of the anoxic zone, you see a dead zone with low N2O concentrations. So it's not optimally mixed there. But if you look at sensor location number 1, for example, there is really a sensor measuring over there. We also took a vertical cross section over there. And now we will zoom a little bit more on this vertical cross section. And actually, if you would measure at the whole depth there, you see that from the top to the bottom of this tank, you really see a 30% difference in N2O concentrations. So yeah, this is just an example to show how important sensor location is to really understand the N2O you measure, and if you need to draw conclusions from that, that you have to take this into account. This was about gradients in a bioreactor, but also these hotspots can really change over time. This is an example of a customer in Canada. So we helped this customer in guiding the optimal location of their future measurement campaign. And here you see the concentrations in the gas phase. And you see in winter scenarios or summer scenarios that there is a lot of variation, or if you have a high load, that these hotspots actually move. So important to take into account.